the core of my thinking I laid out in a short 5-page paper, and then I have the longer slide deck, and both of them you can find linked at this page. And uh, this should be an interactive discussion. Please interrupt with comments, clarifications, questions, answers, or anything at any time, please. Um, let's see.
Do we have a copy of this? Has it been emailed to us?
Uh, if you go to this website, the first link has a list of resources, and under Big Picture, um, well, it's on these slides, but it's the full deck that these slides were drawn from. But I'd be
Bruce
happy to
Wilson.
send
Okay.
out to share the link to these slides.
Yeah, I was just thinking it would be handy for us to go through it, if we on our own computers. Thank you, Bruce.
Okay. Let's see. So, a lot of people will say that, electricity systems are really complicated. You have to understand a whole lot of things about inverters to be able to confidently talk about it. And I would say that's sort of nonsense. That we can decompose the coordination between the electricity grid and the customer into these three domains: energy, power, and capacity. Energy is about load shifting. That's what things that meters measure, and prices accomplish that. And then there's a whole lot of things that inverters do, which to fully understand, you need to be an electrical engineer, which I am not. But really, they're basically entirely separate from the load shifting. And then there's the issue about managing distribution system capacity to make sure you don't burn out transformers or overload wires. And typically utilities don't do that, but they're starting to, and that's a third dimension of this problem. And if you separate those into three problems, you can have the right answer, the right tool for each one, and they can be easily understood. If you throw them all together, it gets very, very confusing. So and then, sorry. So conventionally, electricity customer devices and basically buildings were just part of the grid. It was one big system, in the way that when I was a child, we had a phone in our house. It was black and had a dial. It was just part of the phone system. It had no identity separate from being connected to the phone system. And at some point, people started connecting PV systems to the grid, and so the grid people looked out and they saw, in the midst of our system, there's these which they call DERs, and they said, we better coordinate with them because they could cause disturbances or problems. And so they looked out and saw a sea of DERs. They did not see customers. They only saw the devices inside the customer site. So they wanted to directly control and have visibility to them because that was their model. Now, in Australia, about 5 years ago, or probably more at this point, they had the world's highest penetration of rooftop PV. And on an increasing number of electricity feeders, the distribution system was in danger of being overloaded, so that you would exceed the capacity of wires or transformers. And so they started to say, okay, nobody else on this feeder gets to install PV, and PV in Australia is inexpensive to install, and so that upset a lot of people, particularly since the vast majority of the time there's plenty of capacity. It was only at some peak hours that there was. So then they started instituting a mechanism to coordinate with customers to limit how much they could export, to make sure that they don't collectively exceed the capacity. But they didn't say they wanted to limit how much people could generate, because what happens inside the building doesn't have to actually affect the grid. The only thing that actually affects the grid is what happens at the meter. And so they coordinate with a customer site as a whole. And that's a critical change here. Instead of coordinating with a device, you coordinate with a site. And so what I'm proposing, and my views and K's are like 98% the same, and is that the grids start by looking out and seeing, and they should see a sea of customers and understand that those customers have rich technology inside their site, but what they have doesn't matter. But they can communicate and coordinate with those customers and those customer devices for the mutual benefit of both the customer and the grid, to make sure the grid works well and to reduce costs and otherwise improve the system. So far, so good.
Would you tell us what a CER is?
Oh yeah, yeah. So the term DER, distributed energy resource, is used in the U.S. and elsewhere. Uh, I don't think it's a very good term. It includes devices that are utility devices on the distribution network, in addition to customer devices. Um, and a lot of people use the term to refer only to inverters, to not to refer to flexible loads. So it's not a very useful term uh, in my experience. CER is what they use in Australia. It's a customer energy resource to remind the grid that these are customer devices. The customer bought them, the customer owns them, and if the grid just can't go in and mess with what you do. They can make requests or give you motivations, but it's your device. It's not theirs. And the utility grid people often have difficulty understanding that. So um, the key thing is that I focus on who talks to whom about what. What's the architecture of the system? And since lots of us are architects, we know that system design is critically important. And then once you have to design the proper system before you let the engineers engineer it, you don't want to let engineers run amok without having a good design in the first place. So I work on the IT infrastructure to make it all work. But the IT infrastructure really affects the whole system. And I'm not a grid person. I'm a buildings person. That's what I've done for the last 40 years. So we have
I
each
miss
have
I
customer
missed that
tickets.
word. I missed the key word. You're not a what kind of person?
I'm not a grid person. I don't have training in utility grid issues. I'm not an engineer, but I know a lot about how buildings work and how devices in buildings work and how things inside of, and how devices in buildings deliver services to people. And on the electricity grid, no service is delivered to a human being whatsoever. It's only about moving electrons around. It's only in buildings that you have actually deliver value to human beings. And grid people typically do not understand how buildings work, and I don't claim to understand how the grid works, although I think I've got a pretty good idea. So, um,
Tor has his hand up. You want to say something, Tor? Tor?
Let's wait till
Yeah.
the end if you wish, but uh, I'm just curious how sodium-ion batteries via CATL and BYD are going to change this.
so technology advances, and like if you think about, it's very useful to look at analogies between electricity and data. In For storage, data storage in IT systems has evolved tremendously over the last 50 years. We've got lots of different storage technologies, but storage is storage. They have different time scales by which you use them, different sorts of capacities. So storage gets less expensive, and so you use more of it. But I don't think it changes the system architecture. It just makes things less costly and more
I'll,
efficient.
I'll add a little. I'll add a little bit to that, Tor. You get the structure right, the system can adapt over whatever you change in it, whether it's from outside forces or inside forces. So the key is what Bruce and I have always talked about is you get the architecture right, you get the systems right, and how they communicate to each other, and the system will adopt and evolve. It doesn't, you could have, nuclear fusion and it will work better with the right architecture.
Exactly. Let's see. Oh, do we have a new person here? Chris?
Yeah.
No.
Yeah, Spaceman Chris. That's Christopher Faust. He just came in.
Um, well, why don't I continue, and then maybe after I'm done, you can introduce
Would
yourself.
you would
Sorry.
you would you go back a slide and focus on the first paragraph?
This slide or the previous one?
Or I don't remember. I think it's this
I
one.
think
Yeah.
I think he means the previous. Yeah.
No, no, it was five. It was five. It was number five.
Okay.
Okay, so the grid customer should be a black box. So you don't want the aggregator to look inside the box and manipulate the thermostats.
Okay. Yeah. I I have multiple grid responsive devices. I have zero aggregators. I don't want one. I don't need one. So my house should be a black box with respect to my utility, Pacific Gas and Electric. I did not tell them I installed a heat pump. I did not tell them I installed an EV charger. They do not need to know because all that affects the grid is what happens.
Look right here, baby. It is just Charlotte right there.
Wait.
No
Chris,
spot.
Chris, turn your audio off because you're
Uh,
upsetting the meeting. Okay, go ahead.
Okay. So, anyways, if you adopt that principle, you greatly simplify things, and that's what this model is about. Because the grid people think they need to look inside of customer devices and control things. They're wrong, and that's
And
the
they
problem
never
here. Is
did,
that,
and they never did it before. They never did
well,
it
Yeah.
before.
yeah,
The whole system was flexible, and they had no visibility into it. But now they want visibility.
yeah.
Sorry, editorial comment.
So, that's a key point in a great simplification. And then I have this term I'm proposing of highly dynamic price. Um, like everybody around the world knows what time of use is, TOU. I've been to in the last few years been to Europe multiple times. I've been to Japan, Australia. Everybody knows what TOU is, but we do not have a standard term that reflects the kinds of prices that I'm talking about. So I have proposed this term because we need such a term. And the time interval for pricing is between hourly and 5 minutes. To be honest, I don't think we'll ever get past like 15 minutes because by the time we get to 15, we'll have so much grid scale storage, it will not be worth going to 5 minute retail pricing. I don't know if that's true, but we don't have to decide that now. But basically, nobody who's reasonable thinks that we would ever get past 5 minute retail pricing. And conditions on the grid are different every day. So if the prices are different every day, they're the wrong price. And if you have the choice of charging the wrong price or the right price, you should charge the right price. Um, the prices for exporting electricity from a site can be different from the import, and more customers around the world pay asymmetric prices where the import and export prices are not the same. I have net metering, and I am horribly subsidized for my export electricity, and that raises the bills of other people in my area, and that's not fair. So I wish that was the net metering would stop. I don't have an opinion on how to set export prices, but the important point is that they can be different, and that's fine for buildings. They can deal with that. And
Bruce,
then you need.
I'm sorry. Where are you located?
I'm in Berkeley, California, so I'm in Pacific Gas and Electric territory.
Okay, thank you.
Yeah, and then devices need to plan, so you need to have visibility in the future. Normally about 24 hours for basically for any regular building device, that's sufficient. Um, PG&E offers a hourly price today, and they have a 7 day forecast of prices because they started with farmers who actually can shift over 3 or 4 days as to when they water their trees. But for commercial residential buildings, basically 24 hours is sufficient. And if you want more visibility, if you just assume that the day after tomorrow will be like tomorrow, then you've got a pretty good estimate of what those prices are likely to be.
May I interrupt you here, Bruce?
Yeah.
You said just now, I think, and I know I heard this when I spoke to you last year in person, that you just use an AI tool that you can find somewhere who will turn on.
I don't use any AI tools. Just to be
You
clear.
know, so how
I'm
do
not
you
opposed to them, but I don't have a need for them.
I know, but what is it that allows your devices to turn on in response to price? What is the mechanism?
They just have simple algorithms that look at the prices, and like my heat pump controller optimizes hourly prices, and if it decides, okay, in the next 12 hours I need to run for 5 hours, it's going to look which are the 5 hours that are the lowest cost. I'll run during those times and not during the more expensive times. It's not complicated.
Are you saying that it's like you have a little computer connected to your heat pump and it runs an algorithm that you wrote or someone wrote that
No. It's a commercial product that I bought. I didn't write the algorithm. I didn't design the product. I bought the product. I put it in my house, and it automatically optimizes hourly prices. It's not
Okay.
that
I
complicated.
have a question. Is it based on maybe historical norms for that day or season? And then what would happen if, let's say, there was, and maybe it's because I'm in New Orleans, I'm thinking a disaster or some random spike or change that would be unpredicted?
So,
perhaps.
so this
Bruce,
yeah, Kay, go
if
ahead.
you might,
Oh,
yeah. I want to remind you, Brendan, about the CLEP dashboard, the ProRate dashboard that we did, and it does have the 5 minute interval that Bruce is talking about there.
It's based
And
on
recall, yeah, I mean, that variability there. The questions that Bruce is addressing really are on the computer infrastructure. I'll just put it that way, of communication, of how the device and the utility communicate, and what their basic each of them has their goals as he's describing and so forth. But this is about that dialogue that's going on, right?
Well, yeah, I was just asking a clarifying question, and I was just wondering, is it something like what ProRate's been looking at, where you just
Wait.
look at the average?
I'm sorry to interrupt. It's not a dialogue. It's a one-directional information flow.
Yes.
It comes from the utility who predicts prices, and your device responds to it. There is no communication in the other direction. Is that right,
or,
Bruce?
or the
I
communication
disagree.
direction is the meter readings from the smart meters that report back, or aggregate consumption, because it doesn't matter what any individual customer does. What it matters what aggregations of customers do.
I think that, Myron, there is a communication in both directions, although you don't see it that way. The price information comes from the utility or some provider, and that is the other side. And I guess what you're saying is that the customer isn't giving that signal, but I believe what Bruce was just saying is the meter does that. The meter's response of flowing backwards, of putting power on the grid instead of taking it, is the dialogue.
Yes. Yeah. And so to be clear, the grid works today with terrible prices, okay? So if we improve the prices to offer better prices, the grid will only operate better. It cannot operate worse if you move from worse prices to better prices. And it is a basic function of any business to set a price for their product. If a business cannot set a price for their product, they are incompetent to run their business, and they should let someone else run it who's competent to run the business. In electricity, we have charged terrible prices for 140 years, and people think that's normal. It's not normal. It's weird. It's aberrational. It's dysfunctional. We need to have utilities charge prices, and what they should do, the utilities should charge the prices that are best for the grid. That's their job. And it's the customers then have devices which respond to those prices. And with the combination of those two, you used to have the best possible result. Now, there's questions about how does the utility know what prices to charge, and I have opinions about that. That's sort of disjoint from what I'm saying because that's their job. But that's the key here. We can only make things work better if we have better prices. And if there's something anomalous today, the system goes haywire. If you have better prices, you can only have a better outcome than you have today. Does that make sense? Yeah. So, okay. So the key is that we need to have an inflection point in our technology inside of buildings where we aim for much better technology than we have today, not just slightly better technology. And we've experienced this before when we went from phones to internet communication. So we know this is possible, and there needs to be some foundational technology by which it all works. And on the internet, it's the internet protocol. Everything on the internet goes over the internet protocol. And so we need to learn appropriate lessons from how internet technology provides such amazing services and make our electrical technology much better in a way that is analogous, not the same as, just analogous to that. So one of the key things I've learned over the last 40 years is the best things in life are simple and universal. USB, Wi-Fi, Ethernet, email, web browsing, they're the same everywhere. That's what makes them so good, and they're simple, right? Every email address on the planet is the same, and it's been the same for decades. It's user at domain. And so we need technology which works in any context, whether you're a grid connected or not, any scale, any customer type, any country. And the customer is always right. We need to design the technology around what's best for the customer, and then make sure the grid can adapt. We should not design this around the needs of the grid. We should design this around the needs of the customer, and all that leads to pricing. There's no other mechanism that can do what pricing does, but pricing alone is not sufficient. We also need to manage capacity. So again, I've a longer presentation which goes into the background on this, and we don't regulate internet service providers the way we regulated the phone company, because the underlying technology is different, and the policy and regulation need to be designed around the technology. The technology is changing. We need to radically change our policy and regulation around electricity to accommodate much better future technology.
Bruce, may I ask you something?
Yeah.
Right now, you've made a point which I think is pretty much opposite to what the CEO of Energy Hub would say. He would say, we really do need to control. Why do you think controlling implicitly through prices is better than the way they do it?
Yeah, and actually, the word implicitly is good, because in Europe they use the term implicit demand flexibility, which is with pricing, or explicit, such as with aggregators or direct control. So the utility people believe that you can only make the system work well if you directly control things. And an important historical note here is that in the 1950s, before I was born, um, Bell Labs was considered one of the premier research organizations on the planet. And multiple people went to them in the 1950s and said, hey, there's this new thing called packet switching. We think it's the future of communications. And what did those smart engineers say? They said, oh, yeah, we know about packet switching. We know it cannot possibly work. Therefore, we don't need to study it. And over the coming decades, the Bell Labs and the phone company created digital phone lines, ISDN lines. They basically missed internet technology because they thought it could not work, and they were fundamentally just wrong. And so it's not surprising that the incumbent cannot understand that there's a better future which moves beyond their technology. And that's where we are with the utilities. And aggregators are just a symptom of the utilities.
It
It's
sounds
cool.
like
Reed Christensen, they talk about it all the time. Incumbents never innovate.
Are you guys old enough to remember Rowan and Martin Laughing, where Lily Tomlin
I am.
plays an operator of the telephone company, and someone calls them up and says there's something broken, and she says, "We're AT&T. We don't care because we don't have to."
Exactly. Yeah,
Oh
that's
yeah.
where they are. So many people have recognized this sort of analogy between internet technology and electricity technology, but there is this fundamental difference in that data packets are all different, electrons are all the same. So even though you can learn things from internet technology, you can't just wholesale photocopy them, because some things don't work, some things don't make sense, such as routing electricity makes no sense whatsoever, even though some people propose it. So again, the internet protocols is the fundamental mechanism which drives everything on the internet. And in my last 20 years of thinking about this, I have never come up with a second candidate mechanism beyond price that can move electricity around over space and time in the way that price can. So as far as I'm concerned, there is no alternative. I guess people call that Tina. Anyways, so that's
Um,
the key.
Yeah, this is where ProRate and your ideas really converge, is because ProRate is all about the price signal and rewarding the prosumer in our dialogue for their contributions.
Yeah, so I don't actually like the term prosumer, because I like the term customer. And the fact that some customers export, that's just a basic fact about what a customer is. It shouldn't be seen as something peculiar or different from a regular customer. Any customer should be seen as somebody who might export.
I
Um,
don't plan on making my own shoes and sell them to someone else.
It does seem more
That's
like
how I
a
think
semantic
shoe
distinction.
customer.
Well,
but I export my own data. I create data and I export it to the internet. Does that make me a data prosumer? No, I'm just an entity on the internet.
And electrons are
And data
universal.
can go both ways, and that's not unusual. That's just a normal part of being connected to the internet. Exporting electricity is just a normal part of being connected to the grid. It's not peculiar. It's different from how it was, but it should not be seen as different being just being a regular customer. So, anyways, so um, people proposed time of use prices in the 19th century, and more than 50 years ago, people proposed prices that were more dynamic than even than the ones I'm proposing. The term prices to devices is now 20 years old, at least. I found a paper from 2006. It might be older. I actually contacted Clark Gellings, and he couldn't quite remember when he first remembered the term. So using prices is not a new idea, but the difference is today we have the technology to automate it. And human beings should not look at prices. I have zero interest in looking at electricity prices, even though that's my job. Want to own machines that automatically do that so I can spend my time doing things that are better uses of my time. So that's the key, is we now have the automation to make it highly practical. Whereas before, you could do it in theory, but then, who's going to wake up at 3 o'clock in the morning and know that they need to change the temperature set point in their water heater and do it? Nobody's going to do that. It's not practical. If it's machines doing it, it's highly practical.
I'd like to
So,
introduce something that when Richard Troy told you that we created this clip dashboard. And we decided to set every appliance to do the same thing every day. Namely, the water heater would always charge at 2 o'clock in the morning, and the air conditioner would always run between 10 and 3 p.m., 10 a.m. to 3 p.m. with a certain flexibility, just stays strictly on what we thought made the most sense if we're going to set it one time for the whole year. And we found that saved around 70% of the energy just from that very simple set point approach. I'm sure we could have done better with a lot of, algorithm stuff, but it saves a lot of energy.
so is your
yeah,
point, Byron, that automation might not, be as good as an investment to build into a
No,
solution?
I'm saying, automation improves it, and it's not expensive to do the automation, but you can get a lot just by a smart setting.
In
so
support of Bruce's argument, I would remind us here that that this level of dialogue that Bruce is proposing, or level dialogue may not be the right word here, but this level of connection with the utility is
coordination.
extremely
Coordination is the
similar.
right term.
But I'm sorry, say again.
Coordination is the term.
Yeah. Okay. Excellent. Right. Right. And what we're talking about here isn't. Okay. I don't want to get too lost in the weeds, because the prorate design, is a rate design, is rather complex and has a lot of features to it that would have various aspects that are extremely similar or dissimilar, etc. Blah blah blah. That's a whole nother dialogue. Let's just continue to hear Bruce's point.
Okay, so I want to run through a bunch of slides showing real prices from around the world that customers are paying that have these characteristics. Commonwealth Edison, not a small or obscure company, has offered such prices for about a decade. They're not, say, great prices, but they are hourly and they are different every day. They have very little automation in place. But the people who are on this tariff, they save money and they're happy. These are some research prices from LBL that we created to drive research tests. We created some prices.
Bruce, have you seen the latest dialogues on the Electricity Brain Trust, the EBT list, about great moments in rate design, where it went negative for like a day and a half at one particular site?
So I'm on that list but I read about 1% of the emails because I have email overload.
Right, right.
It's way too much.
Okay, well, let me all right. Let me just very quickly say that full bore real time pricing has its issues, as illustrated here.
I am
I think
opposed to directly linking retail prices to wholesale prices. That wouldn't be good for the grid or for the customer, and that's completely unnecessary. Normal markets do not do that. Other markets do not do that. Whether it's gasoline or aluminum or other things, you do not directly link, or bananas, retail and wholesale. They're loosely coupled. They're not tightly coupled. Here's some prices from PG&E. Some real prices that I, in theory, could have paid, except that I can't pay this tariff because I have solar panels, and that's another problem. That they have hourly prices that are different every day. Southern California Edison is poised to offer the same prices soon. They're already calculating them. They have a price server which uses OpenADR 3 that announces those prices. These are some prices from Scandinavia. Most people in Scandinavia pay hourly prices that are different every day. But I have actually only found price servers in a few places in Australia and California. I have found zero price servers in Europe or the UK. And if you don't have a price server to know what the price is, how can the machine do the right thing if it doesn't know what the price is? And so people have not thought through and set up the automation to make it actually work. So there's different pieces of this that exist everywhere. In California, we've thought about the automation, but we barely have the prices. And so once we put everything together, things can start working well. These are some prices from Australia. Well, I spent half of October in Australia. I became convinced that they have a dysfunctional institutional structure such that nobody really has the incentive to charge the right price. But anyways, that's another story. So here's my definition of a price. So this interval, it has to be either the day before or the day of. It doesn't matter whether it's day before or day of, because my water heater controller, it needs to decide what to do now. It doesn't care what the price was yesterday or tomorrow. It only cares what the price is now in the next few hours. And whether it's day ahead or day of, if the next time it reoptimizes the prices in 10 minutes, if the prices have changed, that doesn't matter, because when it's making a decision now, it only cares what the information is now. So it's like a weather forecast. You can plan, do I need to take an umbrella based on the weather forecast? It doesn't have to be exactly right. It just has to be good enough to plan. And that's what even a forecast of prices are. And of course, they have to be different every day. So this should be the maximum complexity of the prices. So you have a stream of import prices, a stream of export prices if they're different, and that should be the maximum complexity of the tariff as it affects the dynamic operation of devices. If you introduce things like demand charges, which are evil, you then completely screw up device optimization, and we need to charge prices which are friendly to machines, because that's what the prices are for. And we have to understand how machines work and set prices that are good for those machines. Richard.
Can I challenge this is all that's needed? I've got a use case that applies to New Orleans and maybe at the moment some in the Northeast. If you've got a battery that you're offering and energy is needed from the grid, you, as the owner of the battery, need to limit it, so there has to be additional controls. You could easily argue that this has to be built into the batteries, but more advance notice that there's a storm that might take out your power completely is something that the homeowner who owns the battery might want to factor in and consider. Okay. So there are different ways to handle it, but there's a little more needed. That's all.
But that doesn't have to be sent by the grid. That can be
sent by
other exogenous information.
That may not be a financial thing. So the prices are the financial components. You also want to send out a stream of marginal greenhouse gas emission data so that people can take that into account if they wish, because since climate change is real, that there is burdens of electricity, and then you want to send out alerts. And if you think that there might be a power outage or a wildfire, then that might change the behavior of devices and it might change the behavior of people. But those are non-financial. But you absolutely want to send those out to both people and devices. So,
Fair enough.
okay. So this is my system architecture. It's the whole system architecture. It's not the simple version. It's the only version. You have to announce the prices. You communicate it to some entity, which then translates from price to functional control. It can be the device itself. It can be some dedicated device like my heat pump controller. It can be an energy management system that covers a whole building, or it can be in the cloud. They're all good places for optimization, and most buildings will use several or all of them, and so we need to make sure they all work well. And all of these links can be OpenADR 3, whether they're wide area communication or in building communication. And there's this reason that these some of these arrows are light green because the value of electricity inside the customer site can be different from the retail price at the meter. And that's something that very few people recognize, but it's critically important. And if you don't optimize to the local price, you will do the wrong thing for the customer. And aggregators routinely do the wrong thing for the customer because they don't care about the customer, they care about themselves or the grid. And they don't know. So they can't even do the right thing usually, even if they wanted to. So now that we have OpenADR 3, and the orange arrows are traditional communication protocols, but particularly Matter is a great protocol for intra-building communication, and Matter now supports price communication. So as to why you can have a different price inside the building than at the grid, if you have asymmetric prices, let's say you're buying electricity at 40 cents from PG&E, or PG&E, if you export it, if you're a new solar customer, you get 8 cents. What price should your water heater get? Well, it depends on what's happening at the meter. If you're currently exporting 8-cent electricity, that's what the water heater should optimize to. It should not optimize to 40% because that's not the actual value of electricity. And there's at least 7 other reasons why the value inside the building can be different from the retail price, and that's critical for this to work out properly.
May I ask a question?
Yeah.
If you were living in a house that was under the control of the level 3 VPP that the CEO of Energy Hub wants, and the utility is literally using the VPP as a power plant, what havoc does that do inside your home?
Well, if they're controlling the device, they're optimizing, they may take some of your preferences into account, but they're not going to do it as well as if your device was optimizing for your benefit only. And they may not have access to all the information to do the right thing. And they don't have the motivations that you do because you want to have the lowest bill and you have other goals. And it's just their goals are not the same as yours, I guess is the key thing. And so they will make different decisions, and those decisions will be inferior to what you would get if the devices were making their decisions with your best interests only in mind, which is what they should do because you bought it and you own it. So my house. 2.5 years ago, my phone got a free software update from the manufacturer. It optimizes to a greenhouse gas signal when it charges. Many of you on this call probably own the same type of phone, and so if that was a price signal instead of a GHG signal, the communications and the optimization will be the same.
We're talking about just charging a telephone?
Yes. Now the amount of power obviously is very small, but the principle is that it's free, no new hardware, and no burden on the customer to do this. That's the
Gotcha.
point.
I
And
understand.
remember, the first airplane was one person, 12 seconds, 80 feet. 12 seconds, okay? But now, because they proved that you can go for 12 seconds, I can fly to Dubai on a jumbo jet because we scaled the technology. Um, the heat pump, which is my space heating hot water, when I bought this product, this commercial product, a controller, it optimizes to TU prices in the cloud. It now optimizes to hourly prices in the controller downstairs for me in my house. That was a free software upgrade from the manufacturer. And then I recently put in an EV charger. I got this nice new Mini Cooper electric EV. It's super fun to drive. And my EV manufacturer, when I contacted them, was enthusiastic about optimizing to the hourly prices from PG&E.
You traded the
So
bike in, Bruce?
I have a regular bike, which I use today. I have an e-bike, which I used 2 days ago. So I'm multimodal.
If you look behind me, you can see my bike.
But it's on the
Hanging from
wall.
the
It should be
ceiling.
like ready to roll outside your back door.
Looking at you.
Well,
It's snowing over
um,
there.
now
Oh yeah,
it's
I've heard you
snowing. I
have
don't
real
think I'm
weather
going to
out
go
there.
out. I'm not going out there till spring. That's why it's hanging from the ceiling.
Okay. Well, I
Well,
live in Southern California.
since we're talking about bikes, I've actually started a really super tiny little bitty business making e-bikes that are step through because the market didn't provide those when I injured my knee and needed blah 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 whatever the hell. So I got a little exposure to that too. But it's funny to me. It seems interesting that you're gonna have a smart battery charger for your bicycle.
So
Yeah.
what's unique about your heat pump? It
What's that?
responds. Is it that outside unit looks like a ductless mini split or something? How is it controlled?
Oh, okay. So my heat pump is an air to water heat pump. It puts hot water into a 120 gallon tank for my space heat and hot water. I have a combined system. I have hydronic heat, and it cannot communicate. But I have this clever controller, a commercial product, and it can turn the heat pump on and off. So
I
I have a
also have
legacy
hydronic.
device, but I have some electronics. I mean, this also has plumbing because it has flow sensors and temperature sensors, and it optimizes the operation. It fills up my tank to put in enough heat for my space heat and hot water needs as it forecasts for the next day, so that it can decouple when it puts the heat in from when I take the heat out. So it's a thermal battery.
So look, gentlemen, we're coming up on the end of our official time, and I am noticing that the bnordman.com doesn't work either with or without the S in the HTTP portion.
BruceNordman.com.
I get a. I'm sorry.
BruceNordman.com. It's not B Nordman.
Oh,
It's
Bruce, not just B. Okay, all
yes.
right, my bad. Sorry.
Okay. So I think this is my last slide. So here's a list of reasons why VPPs are problematic and pricing is better. I've probably gone through all of these already, but I think this is my last slide of substance. But anyways, the point being that uh, you know we will have VPPs, but over time we should try to make them as small as possible, and we should try to make pricing be as big as possible because we want the value of flexibility to be monetized by customers so they can have lower bills. If it's monetized by somebody else, customers have higher bills. And not only have higher bills, they also lose privacy, autonomy, cybersecurity. They can't operate as a microgrid. There's huge numbers of problems. It's a very stark difference. But we don't need to say the VPPs are terrible. We just need to say we want them at the appropriate size, and we want to make pricing grow as quickly as possible. And I think that's my last slide. So thank you.